What's up, Math 1 students? This lesson's on 4E, which is finding the measure of angles, okay? So what we're going to do is we're going to break this down by each property we will use, followed by examples that use the property. And then at the end, kind of summarize when to, use the combination of properties. So first off, we're going to start with angle addition. And angle addition is similar to segment addition, where the sum of two small angles is equal or equals the big angle. So when I look at the example here, and if I take angle 7 and I combine it with angle 8, those two angles together make this big angle, which is angle DAB. Okay, so that's angle addition. So when we look here, if we had to find the measure of these angles in the first example, notice here, LKJ, I'm actually going to trace that angle, L to K to J. Notice that's an acute angle. So when I measure using a protractor, you have to identify acute or obtuse. Since it's an acute angle, right, I'm going to take the smaller of the two numbers, right? So this angle would be 50 degrees. Now, so angle, let me label that. Angle angle LKJ is 50 degrees. Now, angle JKM, when I look at angle JKM and I trace it, J to K to M. Now notice it's this angle here. And if I count if I start at the 50-degree angle, it starts here, and I go 50, 60, 70, 80, 90, 100, 110, 120. When I go from 50 to 120, or if I take 120 and subtract 50, or just count 10, 20, 30, 40, 50, 60, 70, I know I'm going to get this angle is 70 degrees. Now, if I measure the entire angle, this angle here, notice that's an obtuse angle. So when I go to look at this, I start at 0 degrees and it goes all the way around. Now I'm going to take the top, not the top number, but I'm going to take the bigger number, right? And that angle there is 120 degrees. So when we look here, angle LKM is 120 degrees. And if you notice, right, if I start at this angle and then I continue, I could basically take the 50-degree angle and the 70-degree angle. And if I add 50 and 70, it gives me 120. So that's kind of showing where the angle addition property comes from. Okay. So the next one, right away, we're going to use a combination of this. If I'm looking for URS, this angle here, URS, that's this angle here. If I take this angle and I extended this angle, right, that's going to give me 37 plus 14 is 51 degrees. Now notice here, the next one, they tell you this big angle is 150 degrees. Now, this angle is 94 degrees. Well, if I see these angles overlapping, what I'm going to do is from the big yellow angle, I'm going to subtract this angle. And what angle do I have left? I have this angle left. So to find the measure of that angle MJL, I'm going to do 158 minus 94, right? And that will give me 64 degrees. Now the next one, right? Angle IJK. So from I to J to K, they're telling me this angle is 149 degrees. Well, if I look, that big angle, right, is a combination of this angle and this angle. So what am I going to do with those two angles? I know 18x minus 3 plus 8x minus 4. These two angles have to add up to 149 degrees. When I go to solve this, 26x, this is going to give me minus 7 equals 149. I'm going to add 7. 26x equals 156. When you divide both sides by 26, you get x is equal to 6. Once I know x, now angle IJQ, I'm just going to do 8 times 6 minus 4. 48 minus 4 is 44 degrees. Now I can find the other angle, KJQ. I could either do 149 minus the 44 degrees, right, which would give me 105 degrees, or if I do 18 times 6, right, minus 3, 18 times 6, right, will give you 108. 108 minus 3 is 105 degrees. So you could finish that problem off either way. So the next thing we're going to talk about is congruent angles. And just like congruent segments, congruent angles are angles that have, right, the same measure. Now, anytime we have congruent angles, we always use identical markings, right, in the diagram. Some people may use one arc. Some people may use two arcs. You may use an arc with a tick mark or double arcs with the tick mark, right? You can name them any way. So right away in this first example, they're telling you that these two angles are congruent. So that tells me angle QTR is congruent to angle STR, right? So this angle is congruent to this angle. Now, when I look at the other examples, right? The one tick mark, I know those angles are congruent. So I know angle Y is congruent to angle U. And anything, if I look here, right, that I have double tick marks or double arcs and double arcs. So I know right away that angle K is congruent to angle G, meaning they have the same measure. So if I break it down, if this is 40 degrees, I know this is 40 degrees. If this is 80 degrees, I know this is 80 degrees. Okay? So when I look at the first example that uses congruent angles, right away in this diagram, I notice this angle is marked congruent to this angle. So the first thing I do is I say if this is 32 degrees, I know this is 32 degrees. Now, they're also telling me angle W or XWZ. So X to W to Z. This angle here is equal to 127 degrees. Well, what I'm going to do then is I'm basically going to find the measure of angle YWV, right? To find this angle, what I'm going to do is I notice that this big angle here overlaps with this angle and overlaps with this angle. So I'm just going to take the big angle, 127. I'm going to subtract the 32, subtract the other 32 because I subtract the overlapping parts. And 127 minus 32 will give me 63 degrees. And if I wanted to, I could check my answer, right, by adding all three of these angles up. What should they add up to? 127. Now, example 6, right away, find x in the measure of angle BAD and HAD. So right away, I notice this angle is marked congruent to that angle. So I know angle HAG is congruent to angle BAD. And if those angles are congruent, I know their measures are equal. So 2x plus 8 would equal 3x minus 4. Now I can go ahead and subtract 3x, subtract 8. Negative 1x equals negative 12. And when I divide by negative 1, I get x is equal to 12. Once I know x is 12, now I can plug x back in to find other angles. So BAD is just going to be 3 times 12 minus 4, 36 minus 4. This is 32 degrees. Now, I can plug x into the other one, but I know since they're congruent, that's 32 degrees already. So right away, if I did 2 times 12 plus 8, 24 plus 8 is 32. So angle BAD is 32 degrees, right? That's this angle here. Now, to find angle HAD, so H to A to D. So I'm looking at this angle here. Well, that angle, HAD, is a combination of the 32 degrees and the 56 degrees. And that would give you 58, or sorry, not 58, excuse me. What is that? 88 degrees. Okay. So the next topic, angle bisector. Anytime we have an angle bisector, we know we have a segment, a line, or a ray that divides an angle into two congruent angles. So when I look here, if I told you ray TR bisects angle QTS. So this ray bisects this angle. What I end up getting out of that is two congruent angles. I know this angle, angle QTR, would be congruent to angle, this angle, which is angle STR. Those two angles are congruent. So like midpoint, angle bisector gives you two congruent angles right away. So looking at the first example, they tell me RV, and I like to draw on the diagram, bisects angle PRS, and I'm going to highlight PRS. And if you look at that angle is made up of this angle and this angle. And if that yellow ray, right, RV bisects it, I know that those two angles are congruent. Well, if this whole angle is 130 degrees, I know I'm basically going to do 130 divided by 2. That's going to say this angle is 65 degrees, this angle is 65 degrees. So angle PRV. So from P to R to V, that's this angle here. That is 65 degrees. Now VRS is this angle here that it's congruent to. So angle VRS is also 65 degrees. Okay. Now example 8. JQ. This angle bisects angle RJK. Right away I mark these angles congruent. They tell you RJQ, this angle is 51 degrees. Well, right away, if this angle is 51 degrees, since this ray bisects it, I know this is 51 degrees. So angle KJQ, I know right away, is 51 degrees. Well, if they're both 51 degrees, now angle R to J to K is a combination of the two angles. So I know angle RJK is 51 degrees plus 51 degrees, which is 102 degrees. So this angle is 102 degrees. Okay, the next example, they tell you ray ZR bisects angle DZN. Right away, this angle's congruent to this angle. So if angle DZR is congruent to angle NZR, I know right away that those angle measures are equal. So I'm basically just going to say x plus 40 is equal to 3x minus 20. Now I can go and solve for x. So negative 2x equals negative 60. Divide by negative 2. X is equal to 30. Now if x is equal to 30, I can plug it back in to find these angle measures. So D to Z to R would just be 30 plus 40, which is, this angle now is 70 degrees. If that angle is 70, since it's a bisector, I know this angle is 70. And now angle DZN, right? This angle here, which is the combined angles, that's going to be 70 plus 70. So angle DZN is 140 degrees. So next, we're going to talk about complementary angles. And complementary angles are basically just two angles whose sum is 90 degrees. So right away in this first example, right, they tell me angle A and angle B are complementary. Well, that tells me angle A plus angle B adds up to 90 degrees. Well, find the measure of angle A if the measure of angle B is 68 degrees. Well, I know angle A plus 68 degrees has to add up to 90 degrees, right? Well, if that's the case, what do I do to find angle A? I'm basically just going to subtract 68 degrees, and angle A would be 90 minus 68 would be 22 degrees. Next, perpendicular lines, right? Perpendicular lines are lines that intersect to form right angles. So if I tell you two lines are perpendicular, right away you know they give you a right angle. Now the symbol for perpendicular is just an upside down T. So anytime you are given this, you know right away you have right angles. Boom, done. Okay, so remember, the symbol is an upside down T. So when I look at this next example, they tell you DA is perpendicular to FC. DA, FC. As soon as you know those are perpendicular, you know you can put right angle symbols in the diagram. Now, angle ADB, if I track it, ADB, that's 6x minus 4, and BDC is 4x plus 24. Well, if I look at it, if this is a right angle, what do these two angles do? Well, they add up to 90 degrees. So 6x plus 4x is 10x. Negative 4 plus 24 is going to give you plus 20 equals 90. Now I can solve for x. 10x equals 70. X is equal to 7. Now, they want me to find the measure of angle BDC. Well, if angle BDC is equal to 4x plus 24, now I'm just going to replace x with 7. 4 times 7 plus 24 equals 28 plus 24, which is 52 degrees. Now, if I wanted to find the other angle, I would just do 90 minus 52. Okay? Next, supplementary angles are two angles whose sum is 180 degrees. So you have to commit complementary angles add up to 90, supplementary angles add up to 180 to memory. So if angle C and angle D are supplementary, I know angle C plus angle D are going to add up to 180 degrees. Well, find the measure of angle D if the measure of angle C is 72 degrees. So C is 72 plus angle D equals 180. What do I do to solve for angle D? I subtract 72, and angle D is 108 degrees. And we are done. Okay, so remember, supplementary angles add up to 180, complementary angles add up to. So after we talk about supplementary angles, we're going to talk about straight angles or a linear pair. When I look at the measure of a straight angle, I know the measure of a straight angle is 180 degrees. So if I draw a ray or a line through this angle, I know that these two angles will add up to 180. So a straight angle or a linear pair are basically angles that form a straight angle, right, which is 180 degrees. So right away here, when I look, if this angle is 46 degrees, I know to find the angle of, or the measure of angle MOP, right, angle MOP, I know is just going to be, these two angles have to add up to 180. So 180 minus 46 is going to give you angle MOP is equal to 134 degrees. We are done. Okay. So to find x in this next problem, well, what do these two angles have to do? This angle and this angle. What do they have to do? They have to add up to 180. So 4x minus 5 plus 85 adds up to this straight angle, which is 180 degrees. So combine like terms. 4x plus 80 equals 180. Now I can subtract 80. 4x equals 100. Divide by 4. X is equal to 25. Okay? And we are done. So remember, these two angles make a straight angle, so they add up to 180. Now, vertical angles, right? Vertical angles are a pair of non-adjacent opposite angles formed by intersecting lines. So if I highlight this line here, and then I highlight this line here, I have two lines that intersect to form four different angles here. I have this line. That touches the purple and the yellow. Then I have this angle that touches the purple and the yellow. Notice they're not adjacent to each other. They don't, they're across from each other. Some people call them the kissing angles, right? So when I look at it, these are vertical angles. And what do we know about vertical angles? Vertical angles are congruent. Okay? So right away I could say angle ABD is congruent to angle CBE because they are vertical angles. Now there's another pair of vertical angles such as these, this angle and this angle. And since they're vertical angles, remember, each of these arcs touch a yellow and a purple line. So angle EBA is congruent to angle CBD. So vertical angles are congruent. Now, when I look at this, right away I notice I have these two angles. I identify these angles as being vertical. Since they're vertical, I know angle AOB is congruent to angle COD. So if they're congruent, what do I do with their measures? I set them equal to each other. Now I can solve for x. 2x equals 66. Divide by 2, x is 33. Now, if I have to find the measure of angle BOC is this angle here. What could I do here, right? Well, I'm actually going to find the next angle, which is AOB, first. How do I do that? I plug the value of x in. 4 times 33 minus 6, right? 4 times 33 gives you 132. 132 minus 6 is 126 degrees. So angle AOB is equal to 126 degrees. Well, if I look, now I'm going to say, if that's the case, what do these two angles have to add up to? Well, those have to add up to 180 degrees. So angle BOC now is just 180 minus the measure of angle AOB, which is 126 degrees. So angle BOC is 154 degrees. So the last two problems are a combination of all the properties, right? So right here, I'm going to take the givens. This tells me AD, if I highlight it, AD is perpendicular to FC. What does that allow me to do? It allows me to mark a right angle here, a right angle here, a right angle here, and a right angle here. Those are four right angles there. Now, FOE, if I trace it, F to O to E, this is 3x plus 5. Then DOE, from here to here to here, that is 5x minus 27. Well, in order to find any angles, I have to find x first. Well, what do I notice about these two angles now? This angle and this angle. Well, they make a right angle, therefore they add up to 90 degrees. So 3x plus 5x is 8x. 5 minus 27 is minus 22 equals 90. If I add 22 to both sides, 8x equals 112. Divide by 8, x is equal to 14. Now, once I find that, now I can plug that value back in. So this angle, right, is going to be 3 times 14 plus 5, which is 42 plus 5. This is 47 degrees. Right away I know this angle is just going to be 90 minus 47, or I can plug x back in, but I'd like to say that this is 43 degrees. So now, angle AOF, if I trace it, AOF, you should know right away that that's a right angle, 90 degrees. Angle FOE we just found is 47 degrees by plugging x in. We said angle BOC now. How do we find angle BOC? Angle BOC. If I look, that angle is vertical with FOE. Since these are vertical angles, what do we know about them? They are congruent. So that angle is 47 degrees also. Right? And now AOB. If I look, AOB, right? AOB is vertical with this angle here. These are vertical angles. Therefore, angle AOB is going to be congruent to EOD, which is 43 degrees. Now the last problem, I apologize, I had a typo. So what I want you guys to do is change angle 2 to x plus 18 and angle 3 to 3x plus 40. Okay? Now with this problem, the first thing they tell you is HJ bisects angle GHK. So when I look at this and I highlight GHK, I notice right away that these two angles are congruent. I know angle 1 would be congruent to angle 2. When I mark angle 2 with x plus 18, and I mark angle 3 with 3x plus 40, I know a lot of people are going to see the bisects and assume that we're going to set those equal to each other. But this case we're not, because angle GHK was bisected, so 1 and 2 are congruent, not 2 and 3. Therefore, I look at what else I have. If I look here, that box, right, this box right here tells me I have a right angle. So I know angle 2 and angle 3 add up to 90 degrees. So I know x plus 18 plus 3x plus 40 equal 90. Now I can go ahead and solve for x. So 4x equals 32, x is equal to 8. Now, once I have the value of x, I can take this value, plug it in. Now, I like to plug it in and find things, even if they don't ask me for them. So 8 plus 18 tells me that this angle would be 26 degrees. Right away, since HJ bisects that angle, right, I know angle 1 and 2 are congruent, so this is 26 degrees. So right away, angle 1 is 26 degrees. Now, I can find this angle here, angle KHL, one of two ways. One, I can say, well, if 2 and 3 add up to 90, right? I know angle 3 is going to be 90 minus 26. Okay. Or, which is 64 degrees. Or, I can plug x in here. 3 times 8 plus 4, 40, gives me 24 plus 40, which is 64 degrees. Now, angle 3 is 64 degrees. To find angle 4 now, right? I'm going to look, what do all of these angles have to add up to? They all make a straight angle, so they all add up to 180. So the easiest way to find angle 4 is just take 180 degrees, subtract 26, subtract 26, subtract 64. And when I subtract the overlapping measures, right, 180 minus 64 minus 26 minus 26 gives me 64 degrees. So angle 4 is 64 degrees. Go ahead, try the student practice, and let us know what questions you have.